Good morning, class. Today we're going to continue with slope intercept. I want to remind you once again that you need to probably have this handout available. Okay, we actually did this problem already. And so we're going to go on. Back up, I skipped several pages. Okay, we're beginning section 2.5. Determine the slopes of parallel and perpendicular. We've already discussed that. We created linear functions and we don't do the regression. Now the point slope formula for a line. I gave you an introduction to this on Friday. So let's go ahead. Here, this is called the point slope formula. Okay, where M is the slope and you've got some point on the line. Okay, when you write the slope formula and it goes through this point and it tells you the slope. Here's the slope. Here are the X and Y values of the point it goes through. So in this case, we have our original equation. We substitute the value of y equals 2 here. We substitute the value of x equals -4. Minus a negative gives us the positive. And we substitute the slope. We simplify it a little bit. We distributed this 2x here and here. And then we added a positive 2 to both sides. We'll combine the 2 and the 8. Getting 2x plus 10. And so y equals 2x plus 10, or we could word this f of x, but y equals 2x plus 10 would be the equation of the line. Now to graph it, our y-intercept is the point 10, 0, 10, and our slope is a slope of 2 over 1, we have to fractionalize it. So from our anchor point, we go up to right 1, or down to left 1, down to left 1, down to left 1, and so on, and we draw our line. Okay, we've got another problem. This time, it passes through the point 50, and the slope is -2/3. Okay, here we put the value into the equation, this point slope form. We distribute the 2/3. The 0 becomes a nonentity. So you have 2/3 x plus 10/3. Well, 10/3 is 3 1/3. So 1, 2, 3, and about 1/3. We go down 2, 1, 2, and over 3. 1, 2, 3, right here. This point is also 1 on the line, but using this down and over method, Right there is 1 unit, 2 units down, and then 1, 2, 3 here. And then we could go 1, 2 units down and over 1, 2, 3. Okay. Once again, this is the point slope formula. Y minus y1 equals m times x minus x1. Okay, it goes through that point and that point. This time they didn't tell us the slope. So what we have to do is first use the slope formula. M equals y2 minus y1 over x2 minus x1 to get the slope. There's point 2 and point 1. Here is the slope formula. We're going to subtract the y values, subtract the x values in the same order, simplify it, and we get -5 for the slope. Then we're going to use the point slope formula to find the equation of the line. Looks as though oh, that's a 4 there, not a 1. Okay, so they're using this point 1 in the slope point slope equation. So y minus -4 equals -5, our slope, times x minus -1. That simplifies, we distribute the 5, get the 5x minus 5, our -5x minus 5, and then we move the 4 to the other side. That gives us y equals -5x minus 9. So we go over and we try to graph that. First of all, down here at -9 would be our anchor point. And then from that, you would go up 5, left. We put this over a 1. We would go up 5, left 1. Okay, and then up 5 more, 1, 2, 3, 4, 5, and left 1. Okay, so from down here, we would go up 5 units, left 1, and so on. Okay, now let's talk about this one. It passes through this, and the slope is undefined. If you recall from last week, when we have an undefined slope, that means that it's a perfectly vertical line. Okay? So the only thing that really matters is what is the x value. We look here, the x value is 2. And we know that this is a vertical line. So it's the vertical line at x equals 2. Okay, again, here are our two formulas. Let's work this one that's up here on the board. First, I have to find the slope. So I'm going to take this one minus that one. So I've got -3 minus -5 over 7 minus 2, which is equal to, these become pluses, +2 over +5. So our slope is 2/5. So now I'm going to put this in the point slope formula. Y minus -5, using the first point again, equals our slope 2/5 times x minus -5. First, I want to go ahead and take care of that, take care of this. So y plus 5 equals 2/5 x plus the 5 and the 5 here cancel. So I just simply get 2. I subtract on both sides. Y equals 2/5 x plus 0. Now, what does this mean? This means that it's on the x-axis. Excuse me, it's on the y-axis. So if I have my graph paper here, then that means I have a y value, a y-intercept of 0 right there. And I go up to 1, 2, and over 5. 1, 2, 3, 4, 5. And I go up to and over 1, 2, 3, 4, 5. And here is my line. Now let's talk more about parallel and perpendicular. Okay, parallel, if you recall, are lines that travel through space at the same angle and never intersect. Perpendicular lines, on the other hand, cross at right angles. Now, that gives us special characteristics for the slope on these. Okay, now, what this statement is saying in math speak is that if you have parallel lines, then the slope has to be equal or the same on both lines. That's what that's saying. Perpendicular lines are slopes that have negative or reciprocal inverses. Now, what do I mean by that? If the first slope is 2/3, if they are perpendicular, okay, the perpendicular slope to that, which we'll call M2, would be -3/2. Notice they are opposite of sign and the reciprocal. Here, for the parallel, then if you had M equals 2/3 again, then our M2 would also be 2/3. If it's positive 2/3, it'd be positive 2/3. Now, other than that, your primary tool for dealing with perpendicular and parallel lines is the point slope formula. If the slope of the line is given, determine the slope of the line that's parallel to this. Well, the answer in this one would be -3/8. It would be the same for parallel. For perpendicular, you take the opposite sign and you take the reciprocal. Okay, if the slope is 20, then the parallel slope would also be 20, and the perpendicular slope would be 1 over our negative 20, negative 1 over 20. If the slope is 0, what do we know about a slope of 0? That means that it's a horizontal line. It's going to be the same. And if this is a horizontal line, then a perpendicular would be at a vertical line. So it's going to have an undefined slope in this instance. Give the equation that goes through the point negative 1, 2, and is parallel to the line determined by y minus 3x equals 4. Okay. First thing I do is I put this in slope-intercept form. I can see here that my slope is positive 3. Now, for the parallel line that it's asking about, the slope is 3, and it says it goes through that point. So now we use the point-slope formula, and we do our substitution. We distribute the 3 and take the negative 2 over to the other side. And we get y equals 3x plus 5. Okay. Now, let's look at what that would compare with this equation graphically. Okay, here's a graph paper. To graph this first equation, which I put in this format, my y-intercept is 4, my slope is 3 over 1. Here my slope again is 3 over 1. In the first example, my y-intercept is 0, 4. So I go up 3, 1, 2, 3, and over 1. 1, 2, 3, and over 1, down 3, and over 1. And I get this line. For this line, I'll put it over 1. This time, my y-intercept is 5. Up 3, up 3, yeah, and over 1. Up 3 and over 1. Down 3 and over 1. Down 3 and over 1. Except I've graphed this, my graphing is poor. Basically, what I ought to do if I graphed it correctly is I ought to come up with 2 lines like this. Okay, this one is just shifted up a little bit higher as its starting point, and it's parallel to that one. Well, that graph was kind of a fail. Let's go on. Okay, what does this say? Write the equation of a line passing through the point this parallel to the line defined by that. Okay, now that one up there, I need to rewrite so it's in point-slope form. So x plus 3y equals 6. Take the x over. So I get y equals -1/3 x plus 2. Okay, that's the basic equation. And that basic equation would be here for the y-intercept, and it would go up 1 over 3, up 1 over 3 with a line like so. Now, let's find the parallel line that goes through the point -3, 2. Y minus y sub 1 equals m times x minus x sub 1. Y minus 2 equals 1/3, since it's parallel. X minus -3, which will change. Add 2 to both sides. Y equals 1/3 x plus 5. So this would be our equation of our parallel line. So we graph it. We start out up here, if this is 2, 4, 5. And we go up 1 over 3, up 1 over 3. And this thing is going to look like that. Now, let's do one more on this particular problem. Let's change this word from parallel to perpendicular. Now we're going to find the perpendicular. So if our first slope is -1/3, you know what? I made a mistake altogether. Everything up here is wrong. Everything up here is wrong because I dropped a negative sign. This should have been a negative here. Okay, this should have been negative here. This should have been negative here, which should have made my graphing somewhat different. Okay, so in my first graph, if I graph this one with that a negative, not a positive, then I go down 1, okay, and left 3, 1, 2, 3, and down 1 and left 3, and my line goes like this, okay. You know, I'm having some trouble today. Down 1, right 3. Down 1, 1, 1, 2, 3. I hope you aren't having a bad day. 1, 2, 3. And our graph should go like this. How did I catch my last mistake? Because it's a negative slope and it has to go downhill. So hopefully, if you haven't learned anything out of this mess up that I've done on this problem, I hope that you have at least learned how to recognize when you make a mistake. Well, now let's graph this one with a negative slope. Again, we start here, except we go down 1, right 3, down 1, right 3, down 1, right 3, up 1, left 3, and this one goes like so. Now, finally, I'm ready to find the perpendicular slope. So our perpendicular, that's a perpendicular symbol of slope 1, is +3/1. Okay? So now we use 3/1 in that point to find the equation of the perpendicular line. Y minus 2 equals 3 times x, here 1, if you please, minus -3. Go ahead and change those. Now we'll distribute this. Y minus 2 equals 3x plus 9. Add 2 to both sides. And y equals 3x plus 11. Now we'll graph that. Here's 5, 10, 11 would be right there. Now, this one is going up 3, 1, 2, 3, and over 1. Or down 3, 1, 2, 3, and over 1. And down 3, 1, 2, 3, and over 1. And this one's going to be going at this angle, which if you look at these, if you look at this line or this line compared to that one, they meet at a right angle. So either way, you're going to use the point slope formula. The only difference is going to be the slope, whether it's the opposite reciprocal or whether it is the same slope. And then use the point slope formula. Okay, here's go through the point 68 and it's perpendicular to that line. So first thing we do is we change that line into the slope intercept format. So our y-intercept is 5, our slope is a -5/2. So our reciprocal slope, change the sign and find the reciprocal or the opposite reciprocal. Now we're going to actually solve this. Our slope is going to be 2/5, our point is going to be 6/8, and we're going to use the point slope form. We substitute in the 8 and the 6 and the 2/5. We distribute the 2/5 and move the 8 over. Right here, we've got to do a little bit of common denominatoralizing. Before we can add these two numbers, we have to change this 8 into 40/5. So -12/5 and 40/5 can then be simplified. 40 minus 12 is 28. That's where that 28 came from. Okay, so this was the equation of the line, and that'd be kind of hard to graph, partly because it's got fractions for the y-intercept and then more fractions for the slope. But it could be done. Okay, this time we got another one that's similar. We're going to go ahead and pass by this one and go into our next topic. Okay. This is a very real problem some of you may encounter. I hope you don't. I have. My grandson recently did. He was coming from east to west Wichita and got caught in that road construction, slow down to 50 miles an hour on 235. He had a very expensive ticket. He was doing 67 and a 50. Okay. This problem is dealing with that. Okay. Now, when this says write a linear function to model this, okay, then what you're wanting to know is what's a speeding ticket going to cost if you go that much over. Okay. And what does it tell us? It says it's $100 plus 5 for every mile an hour over. So the cost, that red doesn't show up very well. The cost in dollars is going to be equal to $5 times every mile an hour you're over. And I'm going to go ahead and use X instead of S because my S's look like 5s. Plus $100 to start with. Okay, that 100 becomes your y-intercept. It's your starting point. Another example of a problem like this is you hire a plumber to come out to your house. He charges you a $75 trip charge. That means he's going to charge you $75 before he puts foot in your house, and then he starts charging you so much per hour. Very similar type problem, okay? In this case, it tells us that they were going 15 miles an hour over, which is very close to what my grandson was doing. He was doing 17 over. So let's just go with his example. We'll go with the 17 here. This is 5. So we would have the cost is going to be $5 times, he was going 17 miles an hour over, plus 100. So the cost of his ticket, 5 times 17 is 85. So his ticket cost him $185. Now, what we did here, this is what they're calling write a linear function to model. Okay, writing the basic equation that'll get you your answer or how you get it. Then you go ahead and substitute and solve it. Okay, we want to create a couple more linear models. This is a business model. B is the fixed cost. Sometimes they call that the overhead. Okay, how much it costs you just to do business. And then this is the variable cost, which could be labor, it could be parts, that sort of a thing. Okay. This is the revenue, how much you make. Price per item. Okay, profit, on the other hand, is how much you sell it for.